Hi students, today's topic is on differential calculus. In the first part, we see some synopsis related with the differential calculus. So the first one, what is meant by limit of a function? Limit and continuity. The definition of the limits. A function f of x is said to have the limit L as x tends to a if this difference is small whenever this is made as a small. Symbolically, we represent this one by limit f of x tends to a is equals L. To understand, I would take up like this. When you take up the graph of the function, say at x is equals to a, and I would say take up the L. X is a point in the neighborhood of a. X is approaching a either from the left side or from the right side. Then the function value also approaching it, f of x value trying to approach L either from the left side or from the right side. That is what the meaning. That means when x is approaching a from the left, then f of x will be approaching L. So there are two numbers here. F of x value trying to approach L as x is approaching a. This is written as limit f of x approaches to a is equals L. Where L is called limit of the function, it may or may not be equals to the value of the function. Remember that. And suppose when x is approaching a from the left side and f of x is approaching L, I say that limit is called left-handed limit. When x approaches to a from the right side, then f of x is approaching L, then L is called right-handed limit. Symbolically, LHL can be written as limit f of x approaches to a minus is equals to L, and RHL is written as limit f of x approaches to a plus is nothing but L. Let me define certain important limits. Limit x tends to a, x power n minus a power n by x minus a is n a power n minus 1. Little extension to this one, I would also say x tends to a, x power m minus a power m divided by x power n minus a power n is equals to m divided by n a to the power of m minus n. And similarly, limit sine theta by theta, theta tends to 0 is equals to 1. In the same line, sine inverse x by x is equals to 1. So from here, we could also write down one more thing. Limit theta approaches to 0, sine a theta divided by sine b theta, that is equals to a by b. In the same lines, even for tan also could be written in that way. Coming to the next, another standard limit. Limit n tends to infinity, 1 plus 1 by n to the power of n is equals to e. 1 plus 1 by n to the power of n is equals to e. Here we can also write down limit n tends to infinity. It is nothing but 1 plus a by n to the power of bn. And that is equals to e to the power of ab. Same way, this can also be written. Limit x tends to 0, a power x minus 1 by x is equals to log a. One more formula. And e power x minus 1 by x as x tends to 0 is equals to 1. and limit x tends to 0, log of 1 plus x by x extends to 0 is equals to log e to the base a. And coming to the same formula, previous one, okay, when you take up, so 1 plus 1 by n whole to the power of n tends to infinity is equals e. In place of n, if you can replace by f of x, and where f of x tends to infinity as x tends to infinity, the answer is equals to e, the same way. Okay, let's see that. The next, continuity and definitions. So f of x be a real valued function defined in the neighborhood of a. As I told you that one, L is called the limit of the function when this difference made small as x is approaching to a. Of course, this is an explanation in terms of the analysis. So that can be written in the simplest form, as I told you, that limit f of x approaches to a minus is nothing but L, then L is called left-handed limit. Similarly, limit f of x approaches to a plus, that is equals L, then L is called right-handed limit. And I say the limit value is existing it provided LHL must be equals to RHL. Must be equals to RHL. Next, what is meant by continuity of the function? If the limit of a function exists at a and is equals to the value of the function, when do you say the limit of the function exists? When you say that LHL is equals to RHL and both of them are equals to the limit and that is equals to value, I say the function is said to be continuous at the point x is equals to a. That's a more important point, at the point. So when can you say the function is continuous? In an interval. Suppose if you take up an interval, it is said to be continuous in an interval if it is continuous at every point in the interval. If it is continuous at every point in the interval, the function is said to be continuous in the interval. Of course, these are some of the important formulae that saves our time. This is one of the problem which says time. Limit x tends to 0, root of 1 plus x power n minus root of 1 minus x power n by x power n is equal to 1 always. If you treat f as a set of functions like this one, x, sin x, tan x, sin inverse x, and tan inverse x. When x is approaching 0, as x is a small quantity, then we know that sin x and tan x can all be approached, can be taken at approximately x itself. Similarly, sin inverse x, tan inverse x can also be taken. In such cases, then we consider the different results by using this process. Among that, and one of the very important results are nothing but this and this one are most important results. So f1, f2, g1, g2 are the functions taken from this set. So if they are obtained in terms of sin or tan, sin inverse or tan inverse, or they are existing it, you just replace with a, b, c, d and a plus r minus b by c plus r minus d. And limit x tends to 0, 1 minus cos ax by the function belonging to the set. Of course, here there is one more formula. Limit x tending to 0, 1 minus cos ax divided by x square is always is equals to a square by 2, which helps us in simplifying the problem. Similarly, the other functions. Let's proceed to the differentiation. I say the function is said to be derivable at x equals a provided limit x h tends to 0, f of a plus h minus f of a by h, exists finitely. That must exist finitely. Then I say the function is said to be differentiable at x equals a, denoted by f dash of a, or dy by dx at x equals a. That's how we say the function is said to be derivable. And what is meant by differentiation or differential coefficient? Differentiation is a process of obtaining dy by dx. What is meant by dy by dx? That dy by dx is nothing but actually f dash of x, which is f of x plus h minus f of x by h, as limit h tends to 0 exists finitely. And that f of x must be continuous over the interval. That is called differentiation. Let us see, we know from the previous classes, we know the standard formulae. X power n derivative nx to the power of n minus 1. I am just brushing up the formula. Root x derivative 1 by 2 root x. This is a special case. 1 by x derivative minus 1 by x square helps us in simplifying. And these are the trigonometric functions. Sine derivative cos, cos derivative minus sine, sine derivative secant square, and remaining trigonometric functions, etc. E power x derivative e power x, a power x derivative a power x log a, log x derivative is 1 by x. Next, rule of differentiation. So when the derivative of constant will always be 0, the derivative of a constant multiplied by a function, then you can take out the constant and you can write down du by dx. And the derivative of the sum, linear value. That means d by dx of u plus v. Derivative of u plus v is nothing but derivative of u plus derivative of v, the derivative of sum. Same thing can be applied for the difference also. And the derivative of the product. This is also called the product rule. So first function into derivative of the second function plus second function keeping it as it is, and the derivative of the first function. The next is a quotient rule. D by dx of u by v is nothing but v du by dx minus u dv by dx divided by v square. Quotient rule. Derivative of inverse trigonometric functions. Of course, these are the standard the derivative formulae. Sin inverse x, cos inverse x differ by minus sign. Tan inverse x and cosecant inverse, tan inverse x and cot inverse x, they differ by minus sign. Of course, this is a correct one. So tan inverse x, sin inverse x 1 by root and cos inverse, tan inverse x 1 by 1 plus x square, cot inverse x, tan inverse x differ by minus sign, secant inverse x, cosecant inverse x differ by minus sign. So the derivative of some inverse trigonometric functions can be obtained by using the trigonometric substitution. Yeah, when you go for substitutions and simplifying, you get answer. What is meant by chain rule? Chain rule is nothing but whenever you find the composite function, then the derivative of this composite function can be calculated. The derivative of the first one is outermost function derivative f dash of g of x, and then inner function derivative g into g dash of x. F dash of g of x into g dash of x, put it in the form of like this one. That is called the chain rule. Coming to implicit function and explicit function. So if variable, what is meant by implicit and explicit function? If y is a dependent variable and x is independent variable, y is dependent and x is independent variable, and if you can write y is in terms of x alone, then I say it is said to be explicit function. You are explicitly expressing the dependent variable on independent variable. So example, y is equals to e power x, y equals to sin x, etc. Whereas when you take up a function of the form like ax square plus bxy plus y square is equals to 7, then wherein no doubt y is a dependent variable, x is independent variable, but from this one you may not be able to express y in terms of x as explicitly. So such function is said to be called implicit function. And then parametric differentiation. So how do you find the parametric differentiation? Yes, when x is equals f of t, y is equals to g of t, dy by dx is nothing but the derivative of g by derivative of f, dy by dt by dx by dt. Derivative of one function with respect to another function. U is a function of x, v is a function of x, then derivative of u with respect to v is given by, it is f dash of x divided by g dash of x. That means d by dx of f of x by d by dx of g of x. Coming to logarithmic differentiation, whenever you find one function rising to the another function, okay, x to the power of x, okay, such function type, then we use the logarithmic differentiation. Assuming that y is equals x power x, taking logarithms on both sides, then we find the derivative. We get the answer by taking logarithms on both sides. That is called logarithmic differentiation. Successive differentiation. Of course, when y is equals f of x is a differentiable function and it is derivable many times, and then finding dy by dx is equals to f dash of x, this is called first order derivative. If it is again a function of x which is differentiable, I can find the second order derivative d square y by dx square equals f double dash of x. And continuing in finding out the higher order derivatives is said to be called successive differentiation. Okay, there are certain results which saves our time. F of x by y is equals to constant, then dy by dx is equals to y by x, which is a homogeneous function. And f of x plus y is equals to f of x into f of y. This is algebraic condition satisfied by the function where f of x is not 0 and f of a is equals to constant and f dash of 0 exists. Then I say f dash of a is equals to k times of f dash of 0. And f of x is a polynomial function which satisfies the condition, then f of x can be either x power n plus 1 or 1 minus x to the power of n. Okay. Let's proceed. Now, applications of derivative. We know that when you take up y is equals to f of x is any curve, the slope of the tangent to the curve is defined to be dy by dx. So dy by derivative of the function at a point means nothing but the derivative is nothing but the slope of the tangent line drawn at the point to the curve. And equation of the tangent line y minus y1 equals m into x minus x1. Equation of tangent line is y minus y1 equals to minus 1 by m into x minus x1. This is the normal equation. Angle between the two curves. When the two curves are intersecting each other at a point, at their point of intersection, if you draw the tangent to the one curve, tangent to the second curve, the angle between the two tangent lines is nothing but angle between the curves, where m1 will be the derivative of the first derivative, that means the slope of the tangent line drawn at the point to the curve, and m2 will be the slope, that's nothing but derivative with respect to x to the second curve at the point. Then calculate angle between them by using the formula tan theta is equals to m1 minus m2 by 1 plus m1 m2. This is a formula, provided m1 m2 is not minus 1. Suppose m1 m2 is equals to minus 1, the curves are said to cut each other, orthogonal angle between them is 90 degrees, and if the curve, they cut each other, and therefore one curve and angle between them is 90 degrees. Suppose when the two curves are touching each other, then they say the m1 is equals to m2, the two tangents are parallel to each other, the curves are said to touch each other. Coming to the next one, there's other conditions. The next, subtangent subnormal. When you draw a tangent line, this is the tangent line to the curve and this is the normal to the curve, and if you drop the perpendicular, this length is called the subtangent, projection of the tangent on x-axis. This length is equal to subnormal projection onto this one. And you know the length of tangent, length of normal, so length of subtangent, length of subnormal. Length of tangent formula y1 by m into root of 1 plus m square. This is the formula. And this is the length of the normal y1 into root of 1 plus m square. So we can also write down y1 into root of 1 plus m square divided by m. And the normal is y1 into root of 1 plus m square. Length of subtangent is subnormal. Similar way, you could calculate the other values. Length of subtangent will be y1 by m subtangent, and the subnormal length is equals to, it is y1 into m modulus. Coming to the next one, maximum and minimum value of the function. The necessary condition for the function to attain maximum value, minimum value is nothing but f dash of x must be 0. Okay, if f dash of x is equal to 0. And if f dash is equal to 0, second order derivative not 0 and it is negative, the function is said to attain the maximum at x equals to a. And if the second order derivative is a positive, the function is said to attain the minimum at the point x equals to a. Next, increasing decreasing function. A function f of x is said to be increasing or decreasing in the interval provided it is increasing everywhere in the interval a comma b or decreasing everywhere in the interval a comma b. Of course, these are some of the important results. You know, from the lower class we had seen some area of a square and the perimeter, area of a rectangle, perimeter of the rectangle, area of a circle, perimeter of a circle, volume of the sphere and the surface area, etc. The other values. Volume of a right circular cone, 1/3 pi r square h, surface area pi r multiplied by r plus l, and the curved surface area pi r l. Okay, the volume of a cuboid xyz and surface area 2 times of xy plus yz plus zx. And these are the some of the important time saving results. The tangent will be parallel to the x-axis. Find the derivative of the function keeping y constant equated to 0. And that gives you the required result. Similarly, tangent is parallel to the y-axis. Then dou f by dou y is equal to 0 gives us the required answer. And these are the some of the applications of the geometry. A right circular cylinder that can be inscribed in a sphere of radius r whose height is equal to 2r by root 3. This function attains the maximum value when x is equal to root c and maximum value, minimum at x equals to root c and maximum value at the point x equals to minus root 3. Minimum maximum values are given by f of root c, f of minus root c. That's a formula. And f of x equals to a e power x plus b e power x, the minimum value is equals to 2 root ab. A cos x plus b sin x, the minimum value minus root of a square plus b square, the maximum value is equal to root over a square plus b square. Right? The area of isosceles triangle with the maximum when its height is equals to, when it's a right angle triangle. Similarly, when a quadrilateral inscribed in a circle, a square has got the maximum area. Square will have the maximum area. These are the some of the points related with the applications of derivative. So in the next videos, we will see the problems on the differential calculus. Thank you.